Okay, this one we're going to do is central limit theorem problem. All right, mean is 15, the standard deviation is 4. Okay, of that's the population. And then we selected 13 people at random. All rounded answers, you can't see it there probably, it says to 4 decimal places. All right, here is simple. All we do is put in the 15 that's given. So 15, all right, 15. How come it's not doing that? Okay. And then just put the standard deviation given, okay? That's all you do is given that answer goes there. The mean is the same for the distribution of X bar, which is a sample mean, is the same as a population mean. So 15 goes there. However, you're going to have a different answer here. All right, let's let Excel do that one for us because we're going to grab that later when we do the rest of our problem. So here I put this in there to save time. So the sample standard deviation is the population standard deviation divided by the square root of n, which is 13. So it's going to be, remember, we do our equal sign. Anytime we do a calculation, do the equal sign. So the population standard deviation is 4 divided by the square root. Start typing in SQRT and it'll pop up. Double click it, all right? SQRT is square root. If you just start typing it in, that's what you're going to get for square root. Type in your n, which is 13. Always close the parenthesis and hit equals. Okay, so there is your sample STDEV. Okay, so I like to label everything so I know what I'm calculating. So again, if I show the answer 1.1094, 1.1094. Okay, all right. So now, C, what is the probability that one randomly selected person drinks between 14 and a half and 15 and a half per day? So I am going to we go back to use um, I've sent this in an email how to do this. We want to use the same thing we did in prior sections. Well, I'll just show you. And then, so we have to find the X value for 14 and a half and the the probability for the X value of 14 and a half and the probability for the X value of 15 and a half. So 14.5, the P value, what's the P value, the probability value, and then for 15.5, what is that same probability, okay? So we go in here and we go ahead and use the formulas, more functions, statistical, and we're finding the probabilities. So we use norm dist. I put that in an email to you guys, um, or I'm going to if I haven't. So norm dist, norm, there it is, norm dist, okay? So now the X value, here's the X value. We're evaluating 14.5. So that goes in here, 14.5. Okay. The mean, that's right there. That's 15. The standard deviation, we're using the standard deviation of the sample that we already calculated. And again, do not retype it. Go ahead and grab it. It's going to plop in right there. See how this one says 1.1094, but it calculates, you don't want any rounding errors. So make sure you grab it as opposed to typing that in. And then the cumulative, always type in 1 for the cumulative. Okay. So there's 0.3. That's the answer for the p-value for 14 and a half. Okay. All right. So I'll show you what to do in a minute. Now we need to do the same thing for 15 and a half. Formulas, more functions, statistical. Go grab norm distribution again. Um, norm distribution again. And again, the X, this time it's 15.5. We're evaluating 15.5. The mean is still 15. Okay, the standard deviation, I'm going to grab it right out of here. Okay, and then your cumulative, always put 1 for the cumulative. Now, all right, so now we're going to take this number minus this number. So I'm going to just, again, I'm going to just let Excel do everything for me. I'm lazy, right? So equals this minus this. And there is my answer for the p-value for the probability between 14 and a half and 15 and a half. And hopefully when I go over there, it'll give me 0.3478, correct? 0.3478. There we go. See, 0.3478. Okay, so now for part D, um, is the assumption that yes, it is necessary. I would think so, yeah. All right, so now for IQR, we're going to do 0.25 for this, 0.75 for this, and then subtract the 2 for these, and I'll show you. Okay, so this is that's the answer we got in the last one. So now I go over here, and this time I'm going to use norm inverse to find the x value, okay, since I'm already given the probability value. So no formulas, more functions, statistical, norm inverse, okay, norm inverse, okay, there we go, norm inverse right here. Okay, so now the probability, the first quartile was 0.25, so I put in 0.25 here, and then here's our mean, 15, and then grab our new standard deviation right here. Again, let the computer do the work for you. Okay, so that's Q1 or 0.75. I'll label everything so you know what the heck you're doing, right? So Q1, which is 0.75, that's the X value for Q1. Do the same thing for Q3 then, which would be, no, that's 0.25, sorry. Just trying to think and talk here. Plus, I'm not used to doing this. So now I go ahead and do the same thing for 0.75. And again, I'm using norm inverse. So more function statistical, norm inverse. Norm inverse, there we go. Okay, probability now 0.75, not 0.25. Mean, the same thing, 15. And again, grab the standard deviation that's already calculated for you. Hit OK. All right, so that's 0.75 or Q3, okay? All right, so I'm going to put Q3. That 0.75 makes it look like something that I calculated or something. So Q1 and Q3. Now I just say this one minus this one is, so that should be, so to 4 decimal places, this should be 14.2517. Am I right? 14.2517, I am right. Okay, and this one should be 15.78, no, 15.7483. Let's see if I'm right. 15.7483, correct. Now for this one, all you do is subtract this minus this. I'll let you guys do that. Oh, by the way, I did notice when I did this in class today, this last answer, you use the 2 rounded answers given up here to find your IQR. Don't use this minus this in Excel, okay? So this one, I want you to use the rounded answers to get this last answer. So I'm going to just use my calculator on my phone and do this number minus this number as is. So 15.7483 minus 14.2517 and hit equals. Oh, so 1.4966 is your answer. Use these 2 numbers. Don't use the Excel numbers. Use these 2 numbers here to get the last one. Okay, I hope that helps.